Thank you everybody for coming out. So today, obviously, we're going to be talking about Angular Schematics. So who here has used Angular Schematics before? Okay, and who here has actually written one before? Okay, so who has used the CLI? Okay, as I would expect everyone to do that. So when you think of the CLI, you have commands, obviously, such as like ng-new, ng-generate your components, generate your services, right? Those are schematics, right, that are supplied to you by the library. And when you think about how convenient that makes your life, right, that kind of proves a point on how powerful these schematics can be, right? You don't want to memorize how to scaffold out a whole project. You don't want to memorize, how to write a service. You don't want to memorize how to write a component, right? That's all stuff that, we don't need to memorize that. We can just, use a schematics or maybe a VS Code snippet if you have it, right? So before we get any deeper, I kind of want to do a brief introduction on who I am. My name is Chris Bautista, and I'm currently a senior front-end engineer at Capital One. I think I'll be coming up on my year next month, or what's today? So January, yeah, so next month in February. If you guys are into social media or anything, or you like reading Medium blogs, I use the same handle on everything. So you can find me at Chris Bautista with 3 A's. I use Twitter as well, but I kind of just use it for lurking stuff. So you probably won't find too much stuff on there. And then fun fact, before I was a developer, I did professional photography full-time. So if you're into like photography in general, feel free to check out my site and give me any feedback. Cool? All right, so let's go ahead and start. So what is schematics? And schematics, it's a library that's part of the Angular dev kit that is used to scaffold and generate files. And the Angular dev kit is basically just a library and a set of tools to support Angular tooling, such as the CLI, okay? And it just happens to have some schematics in there for us so we can take advantage of it. Okay, so why should we use schematics? So back to the previous example of ng-new, ng-generate, right? We kind of automate the boilerplate there, right? We can also enforce standards and conventions. So say maybe you guys don't like ng-generate component out of the box. Maybe you guys like writing your components differently. You could potentially write your own schematic and have it look completely different than what's out of the box. And that way you kind of force all the devs on your team to kind of use this command, and everyone's kind of in the same structure, right? And then last is my favorite, faster ramp-up times and start coding immediately. So in my experience, and I'm sure everyone can relate, you say you join like a new project, right? They give you a new task to maybe spin up a brand new Angular application. But when you spin it up, you don't know what dependencies, like what dependencies does my team use? What data tables library, right? Or maybe what version of Bootstrap, right? Like these are questions you kind of have to waste your time asking other developers on your team what to use and who may not even know the answer, right? So what happens is you end up with all these projects on different versions, right? Different libraries, people are using different data tables, and then you just get a lot of inconsistency throughout your projects, right? So what you can do is you can essentially write a schematic to kind of scaffold out a brand new library or brand new project for you and hit the ground running, right? And I'll kind of show you a cool example later on how my team does something like this, and hope it kind of inspires you guys to like bring this back to your team and start writing some schematics, okay? So before we actually start diving into some code, I kind of want to do a brief introduction on pieces of the schematics that you will see when you run these commands. So first, you're going to see one file called collection.json. And this is basically where your schematics are grouped together. So you can kind of think of it as a list of what schematics are available to your project, right? You have another file called your index.ts, and this is just where your schematic codes go. So this is like the meat and potatoes of your schematic. So anything you need to know what it's doing, you can find it in this file, okay? You have another file called schema.json, and this is where you can kind of just define the options available for your schematic. So when you think about ng-generate component, you have to supply a name, right? Otherwise, it will error out and say, I don't know what to call your component. So that's the name option, right? So that's just an example of an option you can pass in. You're going to see another file called schema.d.ts, and that's going to be the type definition of your schema.json. This isn't scaffolded out by the schematic CLI for you. This is something that you will add yourself. So since it's TypeScript, this kind of just gives you type safety over your options. So when I actually show you what this file looks like, it's literally just a TypeScript interface representing your options. And lastly, you're going to see a files directory. This is where you're going to put your template files to replicate into your project. So if you have maybe like a prettier config or something that you want to throw into your application, you can throw it in here and then throw it into the new project that you run your schematic against. And again, we're going to see this all work live, and it'll make more sense in a second. Okay. So important terms before we go a little bit further. There's two main ones I want to go over. We have the tree, which is the staging area for changes containing the original file system and a list of changes to apply to it. So this is basically like a virtual representation of your file system. If anyone have ever used like the dry run flag in your schematics, so if you did like ng-new my project -- dry run, it will kind of spit out exactly what it would do. Let's say like create app component, create this, but it won't actually commit it to your file system. So you can kind of think of that as your staging area, okay? And then you have something called a rule, and this is a function that applies actions to a tree, and it returns a new tree that will contain all transformations to be applied. And that's just a fancy way of saying any modifications I do to anything on my file system is just going to be called a rule, okay? And I have a link here that we can share the slides later, but there'll be more terms on there. Obviously, there's more than two that you can dive in later if you're curious, okay? Last thing I want to go over is something called AST, and this is the abstract syntax tree, and this is probably going to be the most complicated part of schematics. But you don't necessarily need to know this in depth to actually write schematics. Actually, most of the schematics that I'm going to show you today won't even really go too deep into this, but I kind of want to just give you a brief overview on what this is, so when you actually start your journey into schematics, you're not just like overwhelmed with what this is. So the official definition, according to Wikipedia, it's the tree representation of the abstract syntactic structure of source code written in a programming language, right? So what does that mean, right? To me, like, I don't even know what I just read to you, right? So I'll kind of break it down. So basically, when we look at our TypeScript file, right, we see like function, function name, parentheses, some arguments. Then we see open curly brace and close curly brace. And in our mind, our brain parses that code, and we know that that's just a function declaration, right? But when a computer sees it, it's going to be in a completely different, it sees it in a completely different way. So this is basically how a computer sees your code. Okay, and I'm going to show you a brief example of what an AST will look like. So if you guys are curious, I have a link here on the slide that you guys can check out later. But basically, it's a website called astexplorer.net. Right, and basically I can just write some simple JavaScript on the left-hand side, and then it will spit out the AST representation of that code. Okay, so you can see here, as I click on different parts of this function, you see that it will actually highlight different parts of the AST. This is kind of how you can modify files in a deterministic way. So a quick example is, for those who have ran the ng-generate component command in CLI, what you'll see is it will create some files, it will create a directory for you, but it will actually go into your app.module file and add that component to the declarations array, right? So that's an example of how, the AST found the closest module file, found the declarations array, and then was able to insert your component into that array in a very deterministic fashion. So that's probably, when you do stuff like that, like modifying code, you're going to get pretty neck deep into AST.
Can I interject one thing?
Yeah, sure.
What's fun about it is it allows you to apply it, to do all your changes. Like if you have a whole laundry list of changes you can make to a file, it knows if you succeeded on everything before changing the file. So you don't get halfway through an operation and then crash. And
yeah.
Half of your updates are written to disk and half.
Yeah. So I'll show you like an example of what he just mentioned. Basically, it's either all or nothing, right? You're not left in a funky state. Okay? So that's a brief introduction on AST. I don't want to go into this too much because it's just going to blow your mind away, and it kind of melts my brain as I'm sitting here talking about it. But just know, as you start your journey in and you need to modify some code, AST is going to be a concept that you're going to need to learn. And I can't promise it's going to be fun, okay? But I will add that the schematics library does add some util functions for you to kind of alleviate some of this pressure, but obviously there's still some more work to add to that.
Just out of curiosity, does the AST familiarity with it, work interaction with it, tend to have to do all this with schematics, or does it enrich your experience as an AngularJS developer in other ways?
Say that one more time. So are you asking?
Does it only concern, does AST expertise really apply to schematics, or does it apply generally across Angular?
Schematics specifically, I would feel like, because this is the only time you're probably going to write something to automate like code modification or anything. But again, AST, it's not something new. AST has been out for a while. It's just it's just another concept that you would need to modify some code. Okay? So let's go ahead and talk about how we can get started. First, you're going to need to install the schematics CLI. And you can just install this globally here. So you see npm install. And is that big enough for everybody? Can you see that? I think it's OK, right? But basically, you can install it from the Angular dev kit package. And this is just going to allow you to run the schematics binary. So you're going to see on the next two lines, so the first line you see schematics, schematic, -- name, my schematic. This is just a schematic that the schematics library supplies for you that would actually scaffold out a project for you that kind of gives you some documentation, and I'm going to run that for you in a second. And I'm realizing that I'm saying schematic like a million times rapid fire, but it's just how it works. The next command that we're going to use is going to be schematics blank -- name my schematic. And when you see -- whatever, these are just options passing in to the command. So this is basically just going to scaffold out a blank project for me so I can start writing a schematic. And this is pretty much the command we're going to be using for the rest of the presentation. Okay?
Sorry, what does the line before that do? Schematic line.
So schematics is what's going to actually run the schematics binary that you just installed on the first line. And then schematic is actually going to execute a schematic name schematic. They probably could have named it something better, like generate a schematic or something. But that's just the name of a schematic that exists in the library. And so I'll show you what that does right now. So I'll do some live coding. Oh, did you have a question?
No.
Oh, OK, cool. All right, so let me maximize this real fast. Oh, no.
Can you zoom in a little bit?
Yeah, I'll make it bigger. I didn't realize I was going to hide it. I don't know why it's at the bottom of my screen, but whatever. Let me kill this terminal real fast. I don't know why I did that. OK, is that better?
Yeah.
OK, so we're going to do schematic, because that's the name of the schematic that we're executing, oddly enough. And we'll just give it a name. OK, so basically what this is doing, I just created a new directory named Angular DC, and then the schematic actually scaffolded out a project for me that we can now go into and see what's going on. And I won't go over this too much. I kind of just want to show you guys, this is kind of some new documentation that they've spun up for us, just so you can kind of go in and read the comments and it kind of explains some things a little bit better. Let's see. All right, so let me maximize this a little bit. So if you go in here, we see we have our source directory, and then we have 3 scaffolded out schematics for us. We have one called my full schematic, my other schematic, and my schematic, right? Those are just 3 separate schematics. If you look at the collection.json, so if you remember from my slides, the collection.json is just a list of available schematics in your project. So you can see here, you have the schematics property here, right? And then you have 3 or 4 available schematics for you, right? So it's just, so if you look at the comments, it kind of explains it. Excuse the red squigglies, it's just a linter. But this is kind of like living documentation that you guys, I would recommend running this command when you get home, right? So if I remove this stuff. So you can see here, like, I'm not going to explain this too much, but this is just a schematic right now, and they just comment this to death and explain everything that's in there. So if you guys are actually interested in writing some schematics, this would be the first command I would run and kind of just read through this documentation here. They do have some documentation on the README, and there is a link that I'll include in the slide later. But yeah, this is just a dummy project that you can go in and just have some explanations for you. Does that make sense? OK. So let's go back to the slides here. So yeah, so the schematic explain command is the command I'm going to show you on how I generated all the custom schematics that I'm going to be going over in the next slide. So let's go ahead and jump into some examples. So let's pretend that I just ran this command right now. So I'm not going to run it again because I did it before this presentation. We just ran this command, and now I'm going to kind of show you what files you're going to see in the slides, because it's a little bit easier to swallow when it's in the slide form. First, all these distractions in VS Code, and then I'll actually execute it live for you. Okay? So the first example that we're going to do is adding dependencies. So going back to earlier in the talk where I was talking about standardizing library versions across your team, this is a schematic you could write so everyone can run it, and everyone's using like, the same version of Bootstrap or Material, or maybe the same version of Angular or something like that, right? So let's go ahead and get into it. So collection.json, which we just went over in the previous scaffolded project, I kind of want to explain some of these properties you're going to see. So first, you're going to see the schema property, and that just specifies the schema for validation. So you can actually get like some IntelliSense in your IDE, and it'll kind of validate your JSON format. And then you have the schematics property, which is just an object where each entry or key is the name of the schematic. So going back to the last project I showed you, we had my full schematic, my other schematic, just listed out. Okay. And then within each of those schematics, you're going to have a description property, which is just a description of what the schematic does. And then you're actually going to have a factory property, which is a string representation that specifies the file location of our schematics entry point. So this is just saying, OK, in my schematics directory, in the index.ts file, there's a function called mySchematic. That's all that says right there. OK? And then you're going to have the schema property right here, which is where you can specify your options. OK? And I'll show you what that looks like on the next slide. OK, so this is the schema.json. And like I said earlier, this is just where you specify your options. So in my schematic, I just have one option. I have one option just called skip I, which is just a Boolean that will basically determine if you want to install your dependencies after you run it or not. And I'll kind of show you what that looks like in code. And if you don't actually pass that argument in, you can actually define a default here. So if I don't put -- skip I, it's going to default to false. And if I specify it, it will be true. OK? Does that make sense? OK. So, and this is the schema.d.ts file, which is just your type definition file for your options. If you're familiar with TypeScript, this is just a simple TypeScript interface. And as you can see in the previous slide, I only had one option called skip I. So I'm just going to have one property called skip I. That's a type Boolean. And that's literally it. OK? So this is going to be the index.ts file. And this is literally going to be where all the code for your schematic is going to live. So let's kind of ignore the import statements at the top. Can everyone see this OK? Is it fine? OK, let me know if you can't see anything, and I'll zoom in. So again, the goal of our schematic is to add dependencies for everybody. Whoever runs the schematic, they will get these dependencies that we declare. They will go in your project, and it'll install them for you. So first, what we need is we need to know what dependencies we want to install, right? So I just chose a translation library. I chose Lodash, right? And I chose like a masking library. Just three random libraries. So these are going to be the three that we're going to be adding to our package.json. OK? And as you can see here, we have a function called mySchematic. So if I go back to this factory property, you can see here mySchematic index.ts, and then a function called mySchematic. That's what that hashtag means. OK? So you can see how that kind of maps to this function right here. OK? So this function is going to take in an options argument, and that options is just literally what we just had with the skip install property. That's all we're passing in, and we just give it a type schema, and that's basically this schema right here that we just defined. It's just typing right there. Okay. Okay. And then what's going to happen is we're going to return a function that takes two arguments. It's going to take a tree, and it's going to take your schematic context. Okay. More times than not, you're going to be messing with specifically just a tree, but there will be some instances where you'll be using the context, and this example actually has it in here. Okay. So now what do we need to do? We just need to add some dependencies to our JSON. So what we need to do is literally just do a for loop of this object right here, and then start adding them to our JSON file. Okay. So we see here we have our for loop of our dependencies, right? And then with each iteration, we're going to create something called a node dependency. And a node dependency is basically just one of the entries you see in your package.json, right? So like you see like dependencies, and you see like Angular version 6.0 or whatever. That's like what a node dependency is essentially. And for my own convenience, I created a factory function that will just return a node dependency. So if you look at this factory function right here, all this is doing is just returning an object with these 4 different properties. Okay? And I'll kind of go through what these properties mean. So you have your type. Type is just a string, and it can basically the library will give you an enum that you can use called node dependency type, and it's going to have a couple options. So we'll have something called, one option would be like dependencies, another option would be dev dependencies, peer dependencies. If you're familiar with package.json, those should sound very familiar to you. For this example, I just have default, and default is just going to be the dependency section of your package.json. Okay? And then you have your name, which is just the package name, right? So it'll be like Lodash or something. Then you have version, just the version number. And then you have another property called overwrite. And I tend to always specify this as true, because what I believe what happens is if you don't specify it as true and you run this schematic against a package.json that already has maybe Lodash already on it, it will just ignore it because it already exists, so it won't actually overwrite it. So maybe if you had a Lodash of like version 3, but this schematic is trying to install version 4, it won't overwrite it and it will skip it. Okay? Does that make sense? Okay. And lastly, we have this last function here called add package JSON dependency. And this is something that's actually given to us by the schematics library. So there's nothing I need to do on my end to make this magic happen. I pretty much plug in the tree, which is our file system, right? And then the node dependency that I just made up here. And then it will automatically know how to add it to your package.json, right? And if you go up here, we can see we took this dependency from this dependencies file, right? That's given to us by the Angular library, okay? Or schematics library. So right now, actually let me go one more. After we finish iterating through all these dependencies, on this next line right here, this is kind of where we can take advantage of options. And all this line is saying is if we choose to skip installation, or if we don't choose to skip installation, you're going to do context.add task, and then there's a new node package install task, and that's just going to kick off the npm install for you, okay? I don't expect you to memorize this line specifically. To be honest, just like now that you know that this exists, go find my presentation, just copy and paste this in your schematics, so you don't have to worry about that. So basically, yeah, this will run npm install effectively. So this is literally the whole schematic right here. So this is probably not too much lines. I think the only things I wrote myself were literally this object here, and then this factory function, and then like a for loop. But no dependency type was given to me. The add package JSON dependency method to actually go in and actually edit the package.json. I didn't have to write that, right? And then being able to run an npm install automatically, that's nothing I did, right? So there's a lot of, so as you can see here, there's a lot of tools already given to you to kind of alleviate this learning curve, right? So let's go ahead and I'll show you, I'll run it live real fast. And let me go to this next slide. This is going to help. OK, I kind of went ahead of myself. So how do we test this out, right? So I just showed you the schematic. But how do I make sure that it's actually working, right? So what you can do is you can generate a new Angular project. So this shouldn't be new. So ng new my schematic -- minimal. That just means don't create the spec or the test runners or the testing framework. And then I'm just going to skip install just for save time. And then we'll just cd into it, and then we'll npm link into it. We're going to npm link the schematics that I just wrote. And if you're not familiar with npm link, this is basically how you can just basically link your source code locally instead of like potentially publishing your code to an npm repository and then installing it again and then seeing if it worked. This is a way you can work locally versus that kind of stuff. So if you're not familiar with npm link, definitely read up on it. It will save your life. Okay. So let me go ahead and just do a live demo on running that schematic. So I have this project called my schematics test. And as you saw here, I'm pretty much just running the same commands that you saw on this slide. So right now we have our minimal Angular project, and now we can run our schematics now. So what that will look like, let me see, erase that. So basically we say schematics to execute the schematics binary. My collection is called my schematic because you saw the directory of my schematic. And then my schematic is actually called my schematic. So to kind of like unjumble your brain real fast, because I said my schematic like 80 times. If I show you in this collection.json, you can see that the schematic is called my schematic. And I can change that name to something else, like whoopee or something, and we can use it the same way. Okay? So I'm going to execute this. First, I'm going to execute it by skipping the install. All right? So you can see here on the line here, it's going to say update package.json, because that's all we're doing, right? So if I go into my git diff, we can see what actually happened. So you can see here my package.json. I don't know if the color comes out very well, but you can see here we have the translation library added, and we have our Lodash and our masking library added for you. So you can already see like how you can like extend the schematic that I just showed you and make it a little more powerful for your team or however you want to use it, right? And basically, if I don't pass in this skip install command, you'll see how it just will literally update, and then it just runs an npm install. And that's all that's doing right there. OK? Does that make sense? Everyone following? OK, cool. So let's actually take it a step further. That was actually a pretty simple schematic. I want to show you about 2 more examples. The next example we're going to do is just generating a custom service. And this kind of goes back to the discussion of maybe your team doesn't like the way ng-generate service does out of the box, or maybe you guys have another service that you use in specific use cases, okay? So let's go ahead and jump into the code here. And again, this is live recorded, so I'm going to be going through this pretty fast just for the sake of time, but I would advise everyone to go watch this later and kind of follow through it, okay? So this is our schematic right here, index.ts, just like we saw earlier. This is where all your logic's going to be. We have our function here that's just going to be called when we execute our schematic. And this should be familiar. It's just going to return a function that takes in a tree and takes in a context, okay? So I'll go ahead and run these line by line. So the first, what you're going to do is you need to actually be able to access your angular.json. So there's actually a util function that the config library will give you called getWorkspace. And all you got to do is just pass in your tree here, which is passed in right here as an argument. And this is literally just going to return your angular.json. So right now, this workspace is equivalent to your angular.json. And are you guys familiar with what angular.json is? More or less? OK. So if you're on version 4 or previous, it was called like CLI.angular.json or whatever. And that's basically where all your config lives for your project. And then I think after they upgraded to version 5 and above, they just changed the name to angular.json and gave you more configurations that you can do, okay? So this is just the angular.json file, okay? So we do some assertions here. If you don't pass in a project name, I'll actually go in and manually do it for you. So let me show you what this is actually doing. So we have something called workspace.projects. So if we go into our other project, I'll show you what angular.json actually is to kind of clear things up. Let me collapse all this. So this is angular.json. Can everyone see that? I'll maximize that. And again, this is the configuration. So you're going to see this property called projects. And you're going to have two properties here. And by default, they'll just have your actual project that you just scaffolded, and then all the configuration there, and then your end-to-end configuration if you chose to scaffold that out. So what we need is we need all the metadata that's in here. And this will have like your root, your source root, your prefix, prefixes apt, and stuff like that, okay? So I'm not going to go too far into that, but just know that it's grabbing that section, okay? So what's going to happen is we're going to grab the first entry, which was my schematics test project. And then we're going to do one more assertion is if you don't pass in a name, so you can't generate a service unless we have a name, right? So if you don't give me a name argument, I'm going to just kill everything and tell you that I need a name. And I'll kind of live demo that for you in a second. You have this get project, which is another util function, which again is going to just grab everything right here. So this is your project right here, my schematics test. That's the project that we're in right now. It's just going to grab all the configuration data for that. And if you're ever curious, you can just console log these things, and it'll spit out in the console for you. Okay? And then next, we need to know, like, where do we want to put it? So one of the options that this schematic's going to take is going to be like a flat argument. And this is something that already exists in the current ng-generate service schematic. So if you want it to be flat, it won't actually generate a directory for you. It'll just put your files like in the root directory. But if you decide, if you don't actually specify flat, it will actually create a folder called my service and then put your files in there. And again, we'll see this work in a second. All right, and then lastly, we're going to create what's called a template source. And all this is saying is I'm going to apply a bunch of rules to all the files that exist in this directory. And this directory is found right here. So you can see these two files right here that have super crazy names, which I'll explain in a second. Apply all the rules to those two files, OK? So we have one rule here, which just says, do you either want to generate spec files or not? If you do, we'll just filter out the spec files. Otherwise, we'll scaffold out the spec files for you. But then we're actually going to run each of these files through a template engine, OK? And then for your template engine, you're going to pass in an object, OK? And we're actually going to spread. So there's something called strings, and this is just a string util library that's supplied to you by schematics. So it has like functions like classify, dasherize, and you'll see what that looks like in a second. So we'll spread those in. And then our options, which would be like option name, option project, or like the path that we want to specify, right? So we'll spread all those in. You can think of this as your view model, right? Or like your scope of the template that we're about to see. And again, I'm going to dive into the template and we'll see it work. And then lastly, where do we actually want to put these files? Do I want to put it in the root? Do I want to put it in another directory? We can define that there. Okay? And then lastly, you're going to see this command called merge with template source. And all this is going to do is it's going to merge the files that you just applied all these rules to with the existing file system. And that's all that's going to do. Okay? So you have your file system, you have these new service files that you want, and then you're just going to merge them together. Okay? So let's talk about what these funky file names mean and how the string utils work out and how the options work here. So right now this looks super crazy, right? Right now this is just, if you're familiar with, if you currently write in Angular, right? This is essentially what a service is scaffolded out by default. The only things I added were like this private destroy, and then I added like a onDestroy lifecycle hook. So just to kind of give some context of what this code means, more times than not, you guys are going to make some HTTP call, right, in your service. But you can also unsubscribe from that by, if you guys are familiar with ArcGIS, I'm not going to get too in-depth with it, but you can do something called like take until, right? And that way you can kind of automatically unsubscribe from things, okay? But yeah, let me back up a second and show you what this is right here. So other than all this other code, it's basically going to be copy and pasted into your project. The only things that are going to be dynamic is what you're going to see in this like less than % sign, which kind of looks like ASP, right? So basically the only thing dynamic about this file is this thing right here, okay? And you can kind of think of this, if you're familiar with just Angular interpolation in general, you can replace those mentally with something like that, right?
If you care to do research, it's EJS syntax.
Oh, okay, there you go, EJS syntax. So yeah, so basically all that's saying right now is saying function classify, right? Because as we saw in the previous slide, we're actually spreading our string utils in, so now we have access to all these utility functions, and there's one called classify, right? So now that we have access to that, we now have access to the name option, because if you see here, we spread all our options into the template. So if we had name, path, or whatever, those are all now available to our template, right? So obviously we need to pass a name or we can't create a schematic or create a service. And this is just going to be name, right? And this could have been foobar, right? And all this is going to do is classify it. So foobar literally just becomes foobar. That's what the classify thing does. That's all it does, okay? Does that make sense to everybody on how that works? Okay. Now, we also have the spec file. Same story. You're going to see these syntax here with the %equal sign. Same story. You have classify name. You have access to the classify function because we spread it in there. And then you have access to the name option, again, because we spread it in as well. And that's what these mean, okay?
There's a whole bunch of things in string function as you're building templates. There's dasherize, classify.
Yeah.
Essentially what it does, it takes your name and it gives it to you in the format of how you would call it. So like if you generate a component, you call it dasherize, right? So it'll give you name dash component.
Yeah, so if you dasherize something, right, and basically foobar becomes foobar. That's all dasherized. You see it just hyphenated it. That's all that means, okay? So let's kind of actually see this work live, right? So I'll go ahead and go back to our schematics test project. Let me undo all these changes here. And then we'll run this schematic. So this schematic is actually going to be called my service. If you look in the collection.json of this project, it's identified as my service, and that's how we're going to reference the schematic I just showed you, okay? So we'll change this to my service, and I'll run this real fast. And it's actually going to blow up because why? Because I didn't supply a name argument, and you'll see an error, option name is required, right? So let's go ahead and supply the name now. Hello world. And you can see here that it just scaffolded out a spec file and a service file. So if we go back into our project, we see that it scaffolded out this folder called Hello World. And now we have our files here. And you can see here, this is the part that was replaced. Let me zoom in on that. This hello world right here, remember that was what was in those less than parentheses sign. All it did was run classify and then the name argument that we passed in. So you can see that's all it did here. Just made hello world in a conventional class syntax. Okay? Does that make sense? And kind of let me do one more. Let's do with the flat option supplied. So you can kind of see how that works. And you can see how it just basically scaffolded hello world not in a separate directory. It just put it in the root right here. And that's kind of how you can take advantage of the flat flag. Because not always, you always want to create a new folder. Sometimes, like when you're in Angular, you notice that you just have like a million folders for each of your services, and you kind of just want to keep them all in just one directory. So that way, that's where the flat flag comes into play. Okay? So let's get into our, well, any questions? Is everything, I know I'm going through this relatively fast, but again, it's live recorded, and I hope you guys watch it again and try to understand this even better. Okay? So for good there, I want to do one more schematic, and this is adding jest. So my team at Capital One, we made the conscious decision to not use Karma and use jest as our test runner. I won't get into reasons why, but I kind of want to show you how we use schematics to alleviate this pain on not having to do this manually on all our new projects. Okay. So let's go ahead and spin that up. 1 second. Okay. All right, so jest. So again, it's going to be a similar format. I'm kind of just going to run through this briefly, but then I'm going to show you the power of it when I execute it, so you guys can see everything run live. Okay. So since we're replacing Karma with jest, there's a couple things we want to do, and I'll show you here. First, we want to add the jest files, right? We also want to add jest to the package.json, and we also want to just kill Karma completely, right? We want to remove the Karma dependencies, we want to remove the Karma files, and then add any other dependencies we need specific to run jest in our Angular project, right? So these are like 5 tasks that I've broken up to be more readable. If you wanted, you could have these all in one monolithic method and not really be readable, but I chose to break them up into separate rules. And you'll see here, this is a new method that you're going to be seeing called chain. And this is essentially how you can chain multiple rules to a tree. And basically, as these names of the functions suggest, these are modifying the tree in different ways. Okay. So let's go into the first one, adding jest files. And this is a pretty straightforward task. This is like some low-hanging fruit that I think you guys could use right off the bat. So if we could jump into this, we're going to return a method, again, that just takes a tree in the context. And then we're going to apply rules, again, like our last schematic, to all the files in this directory. And that says files config. So this is basically these 2 files right here. So we have jest global mocks.ts and setup jest.ts. And these are things that are kind of just boilerplate for a library that we're using called jest preset Angular. So effectively, all I've done was take the README and the instructions and automated it for myself, because it's not something I want to do over and over again. And this is not something I want other developers to have to do as well. So why not just make it easy for everybody? Okay? So let's go back to the schematic. So all we're doing here is saying those 2 files I just showed you in the config directory, literally just move those to the root of my project. And that's all I'm doing, right? And then we kind of give them some messages saying we're basically going to for loop through all the files in the config library. So it's literally just going to iterate over jest global mocks.ts and setup js.ts right here. And it's going to say, if it exists, let's just display like a nice user experience message saying, OK, hey, we actually overwrote this file. If you didn't mean to, go in your source control and undo it. We just give them, so they at least know that we just overwrote something that existed. Okay? And then we have a method that's applied to us through the tree called overwrite. And basically what we're going to do is pass in the path and then pass in the content. Okay? And that's just going to overwrite the file if it does exist. Otherwise, we just move it in there. Okay? Does that make sense? Okay. So if we go into the next rule, this is just going to be adding jest to the package.json. And it's going to, like kind of similar to the first schematic I showed you with adding dependencies. It'd be somewhat similar. So there's actually another util method. I either took it from Narwhal or I either took it from the CLI source code. But basically they have all these util functions that you can just like rip out and use for yourself, because why reinvent the wheel, right? So they have this method called update JSON in tree. And basically what you can do is you just give it a path, and then it will basically serialize that JSON for you. So we pretty much pass in package.json because that's what we want to parse down and edit. And then in this callback, it will actually return to us the serialized JSON, right? So now, as web developers, we're all familiar with JSON and messing with that stuff, right? So now that I have JSON, this package.json here, I can just do .jest, which would either add it or replace it if it does exist, and then just basically add all this boilerplate in that object. Don't concern yourself with what it says, but that's all I'm doing. I'm literally adding a property to my package.json called jest, and then just throwing in all this boilerplate that the README told me to do. That's all I'm doing. Okay? And then next, what I want to do is I want to actually update my npm scripts. So in the package.json file, there's like a script section that you can run to automate or run some commands that you want. So I'm actually going to get a reference to that. So package.json.scripts. So now I have the reference to that here. And I'm going to say, OK, whenever I want to add or replace the test command and change it to jest -- verbose, which is just a jest command that you can write. And then I'm going to add another key here called test watch, and just another jest command. And it'll make sense. I'll run the schematic for you so you can see it work. But that's literally all I'm doing. OK? So as web developers, we've been messing with JSON forever. It shouldn't feel too foreign to you on that piece. OK? And I'll go over like two more. Let's see here. We have remove karma dependencies, right? That's something, if we're not going to use karma, why should we have it in our package.json? Because obviously if you run npm install, it's just going to install all this other stuff that we're just not using. OK? So same thing as adding them as the one I just showed you. I'm going to use the update JSON in tree method again. Have reference to the package.json stuff here. And then I'm going to say, OK, in dev dependencies, if there's a dev dependencies, use it. If not, just instantiate it as an empty object. OK? And then what I'm going to do is I actually have an object that lists all the dependencies that I want to get rid of. So if I go here, here's a list of all the karma stuff that comes out of the box when you scaffold an Angular project. And this is all the stuff that I want to delete because I'm using jest now. I'm not using karma. Right? So it's just an array of strings. And these are just going to be dependencies in my JSON, right? So all I need to do is just loop through that array and find that dependency. And if it exists, just simply delete it. And that's all we do. Straightforward, right? Cool. And then lastly, we want to remove the karma files. Because when you do ng-new, right, you get a karma config file and you get a test.ts file, right? And since we're not using those, let's just kill those, right? So we just literally do a for loop. And since we have reference to the tree right here as an argument or as a parameter, there's a method called exists. So we can check if the file exists here. So all we're doing is saying loop through this, check if it exists at that path. If it does, delete it. And that's all that does. And this is the safe way of deleting files. If you don't check if a file exists before deleting it, I believe it just blows up saying this file doesn't exist that you try to delete, and it'll just short circuit your schematic. So this is like the safe way of doing it. OK? Does that make sense? OK, cool. So I'm going to cut that short because I don't want to just keep like spitting code at you. It's kind of like boring, right? But I kind of just wanted to show you like a lot of the code that I've written for schematics, I've took advantage of methods that are already supplied to me. I don't need to be an expert at parsing JSON and doing all this stuff. I just take the utils that are given to me, just learn with the tools that are given to you, and then make something greater out of it. That's all we're doing. And obviously, like it's super intimidating trying to jump into schematics. First, because there's not a lot of documentation. So how I learned is I literally just cloned the Angular CLI repo. I cloned other open source repos and kind of just looked at the schematics they're doing and kind of looked at like, are they accomplishing the same goals that I want to accomplish? And then kind of just like, reverse engineer and take bits and pieces of what I liked and what I didn't like, okay? And I would advise, if you guys are tinkerers or you guys are curious, I would advise you to do the same. But now that schematics has been out for a little bit, there are lots of good blog posts out there that can kind of get you started, okay? So let's go ahead and just run this Jest schematic just so you can just see what's going on here. Let me make this bigger because I can't see anything. Sorry, give me 1 second. Actually, that's the wrong one. Okay. So let's run this Jest schematic, and then you'll pretty much see everything I just like spit at you. You'll see like how that works in real life. Okay. So, Jesus. Sorry. Technical difficulties, live coding. Okay, let me run that one more time, sorry. So going back earlier, all I'm running is schematics, and our package name is just called CI Catapult, and then the schematic is called Jest, right? So this command that I wrote, that I've executed multiple times during this talk, that's all that's saying. So npm scope c1, collection name CI Catapult, and then the actual schematic that I just went over with you is called Jest, okay? And that's how you execute that. So let's actually look at the git diffs. You can see here, well, actually let me back up. You can see here these two files that were in the config folder. You can see that they were just added to the root of my Angular project, right? And all that literally did was just literally just copy and paste it into your project. We didn't actually have to write too much code besides saying move to the root, okay? We see our package.json. This is where it gets interesting. You can see here, I overwrote the test command from ng-test to jest verbose. I added another command here with jest.watch, right? You can see I added all my dependencies here to be able to use Jest in my project. And then you can see here that I just deleted all these karma dependencies here. I don't know if the red's coming through for you, but they're deleting them essentially, okay? And then the boilerplate that had that long, big object, you can see here that I simply just added a Jest property, and then it just spit out that huge object into my package.json. And that's all. And they pretty much did all that for me. I didn't have to learn how to manipulate my JSON file, really. Okay? Yeah, and then so also here, I deleted the karma config file, and I deleted the test file as well, because these are just all things that you don't need. Okay? So if we actually, I think it actually, did it install? Let's see. Okay, cool. So this is going to fail, but this just proves that, you know, out of this brand new project I just scaffolded, I just ran one schematic, and now you can see I can execute Jest out of the box. And now I'm no longer using karma. And if you're a developer on my team, that's literally all you would have to do, and this is going to work for you. You don't need to, you know, reference my project and like go through all my commits and try to compare if you're going to make any mistakes or not, right? Does that make sense? So you can see like how that just makes your life so much easier. Okay? So let's go back to the slides. So I kind of want to show you how my team is leveraging schematics today, and like all the cool stuff that we're doing with it. Okay, so if you ran ng-new today, this is what you get when you try to serve it out of the box, right? You just get like this ugly template file that has links to like documentation, right? But if you, after this, you run our schematics, we give you like this scaffold out project with custom components. We give you analytics. We give you translations. We give you our CSS framework out of the box and all this stuff. And I'll execute this for you live and kind of show you how the site works. But you can see here, right? Like, if someone was joining a new team and they needed to start a new project, like, wouldn't it be better if you just like had this and you can just start coding, right? Like, you don't need to worry about headers, footers. You don't need to worry about what CSS framework I should use. Or maybe what conventions I need to follow. We kind of supply all that for you, right? So let me go ahead and execute our schematic real quick. Let me undo these changes real fast. And then I'll run our cool schematic. Are we good on time? OK. This is the end, but we're cutting it close. So pretend that we just ran ng-new. We have a new project. And I'm like, hey, Chris, I want to start a new project for some ticket I just got. Where should I start? I would literally point you to this schematic to install, and then run this on your run this on your ng project essentially. So you can see here, it just did an insane amount of things, right? And you see all these crazy messages. Basically, I'm overwriting a bunch of stuff and I'm just saying, hey, I overwrote this. Did you want to do this? If not, go fix it, right? So you can see here, we're deleting Karma, we delete Protractor, we're adding in Cypress files, we're adding in Jest files, we're actually overwriting some of your default components, and we're updating a bunch of stuff here. And I'll kind of walk through that briefly and then kind of show you how this works. So going back to how my team made a decision to use Jest as its testing framework, we also made a decision to get rid of Protractor and use Cypress as our end-to-end framework. So we're currently using Cypress for end-to-end. So let's kind of make sure everything's working. So if I did like npm run end-to-end, we should see the Cypress Electron app launch. It might have launched on a different page. Oh, OK, never mind. There it is. So this is actually Cypress. It's not going to work because I don't have a server spun up. But you can see now, like, I haven't done anything, but I can now use Cypress now. I can start writing Cypress tests right now if I wanted to. Cool. And let's just make sure, let's go ahead and just make sure that Jest is working properly. Or that's not the command. npm test. And we should see, so that alone just, that's what Jest looks like when it's running. So it's going to fail, but now we see that we're no longer using Karma. We're now using Jest out of the box. And this literally took me like a minute to do, right? So before I dive into more stuff, I kind of want to show you some other things that we're actually doing with our schematics briefly. One is if you generate your Angular project with ng-new, by default, it will just do .css. We use Sass on our projects. So what we'll do is we'll actually delete your .css file, replace it with a .sass file. But I'll also go into your configuration in your Angular.json, and I'll update your configuration to always use Sass files when you run ng-generate. OK? So let me show you what that looks like briefly. Where's Angular.json? OK, right here. So you can see here. Ignore this stuff. Some of this stuff is like specific to our team. Where'd it go? Oh, I think I'm using the wrong branch. But what would happen is I would add something in this schematics property here that would just say use Sass as your default style or preprocessor. Okay. Some other cool stuff. If you've ever scaffolded out an Angular project, it always gives you these app component files. So we'll actually delete all that nastiness that it gives you, that ugly template, and we'll actually replace it with a component library that we've written ourselves internally. So we'll give you this header, we'll give you this footer, and kind of just have configurations built in for you. And it kind of already utilizes some of our custom CSS classes that we have. So you can see here, like we already replaced that for you, right? If we go into your app component actual TS file, you can see here, like out of the box, I think all you get is this title thing, right? This title property. So you can see here, we have all this stuff already scaffolded out for you. You can see here that we replaced the .css file with .scss. And then we give you all this configuration that's going to kind of drive the header, drive your translations and your analytics. So I'm not going to go too much into that, but you can kind of see like out of the box, you get all this stuff, right? So let me kind of just spin that up real fast because I think it's super cool. So we'll just do ng-serve-o. Let's see. I mean, while that's spinning up, we do other things like if you're familiar with the environment files, we do have specific endpoints for certain environments. So we will overwrite your prod.environment file. Let me back up. We will override some endpoints here in your prod and QA environment files. Just some stuff that's just specific to us. Oh yeah, and lastly, the favicon, right? I think there's like an Angular favicon. We'll go in and replace that as well because you don't want to show that in production, right? So now that this is spun up, okay, so right now, just by running one schematic command, you see I have a custom CSS framework. We have all our components added, all our dependencies installed. Now I have translation out of the box. You can see the header, the footer and header are now translated, and I literally did nothing. I just ran a schematic. So can you kind of see like how this is like super powerful? So if you do something like this for your team, right, I would encourage everyone, if you guys have conventions or anything, like I think this stuff is super cool. You save hours of dev time. You save hours of maybe typos that you could have possibly done when you rip out Jest or rip out Protractor, right? Those are all prone to human error. So
can you show, just for standardization and stuff like that, it goes beyond Angular, you can show them the VS Code directory. I don't have a problem with that, because that's in our schematic as well. So if you look at VS Code directory.
IntelliSense.
Yeah.
You're talking about like this stuff right here?
Yeah, so you can actually control and have common VS Code settings.
Yeah, so like if you guys use Prettier or something, or you guys have like certain formatting, like you guys argue about formatting all the time for whatever reason, you can just add that in there. So you can add Prettier configs, you can add an extension.json, which will actually recommend plugins that we want you to install that kind of, that kind of streamline your workflow. Then you have settings.json, which will just pretty much override some defaults in your workspace. So you can see here we have like some Prettier configs, because we advise you to, at least on our team, we advise you to install like the Prettier extension, and we'll just like add some rules in there for you. Cool?
So hey Chris, I wanna come back to your question from earlier about does AST understanding an abstract syntax tree make you a better Angular developer?
Oh, is that what he said?
The answer is not really, but. And the but is as you dig more into how the parser parses your TypeScript, your JSON, you learn a lot about structure of your code, which is always a good thing, right? But two, it's more the hill you have to climb to understand how to do all these like things with schematics, which make you a much better Angular developer, especially if you are dealing with, think about like an Angular library as opposed to an Angular app, right? If you're writing NGRX or Material or something like that, having these tools available to you to give to you, right, is where it becomes really super powerful. And for us, it helps us write a little bit cleaner because we understand that at the end of the day, when somebody on our team writes a component, if we write a service and we have a breaking change, we're probably going to have to write a schematic to go in and fix that component. So our code reviews are better because we're thinking about like how do we keep our components simple.
And is an NG update basically a schematic? That's all it is.
Yeah.
NG update uses.
So to give you like some other examples, like they're talking about with NG update, right? These are schematics that Angular will give you. So say you're like on version 4 and you want to go to version 5 or something, they will actually alleviate some of that pain and use a schematic to update all the breaking changes for you, right? So that's like another example of how you can use schematics, right? So like maybe you're a library author and you have a breaking change. You can write a schematic so people can just execute this, and they don't have to go through like a README and be like, okay, what do I need to replace? You can just automate that for them, right? But that's when you get dirty into AST, and your head's going to potentially explode, and you probably won't want to write a schematic ever again after that. But if you're curious on who these people that keep talking, he's my technical lead, and he's my manager, so they're not just rude. I'm used to this.
I mean, AST is a deeper topic, but I mean, some of these utilities are valuable in case you've got a really messy project and you're just like parachuting into.
Mm-hmm.
If you want, for example, to map out the dependencies,
Mm-hmm.
good luck.
Mm-hmm.
But, that's one way to try.
Mm-hmm. Did you have a question?
Yeah, how do you keep your templates that you have in your schematics? I know it's a TypeScript file, but you have non-TypeScript syntax in there. How do you keep that?
What part are you talking about?
Like the stuff you mentioned that had
Classifying the dasherized stuff?
the name that you.
Yeah.
Oh, okay. So you're talking about the earlier examples.
Why don't you
Yeah.
go into the dev kit and show what classify and dasherized actually
That's too much work, man. Hold on. Let's do step by step. Let me take you back to that template file because I actually just saw a really bad mistake I just did in my live demo, and I'm going to explain that in a second.
There's this thing you call the ASP tags, right?
Yeah, EJS.
EJS, yeah.
So when the schematics actually run and copy the files, they parse that TypeScript file or that HTML file into an AST itself. And then those classify functions actually run. And so in the syntax tree, it becomes a class name or a dasherized component name or an uppercase or a lowercase.
Yeah, but for maintenance purposes, how do you keep that linted? Do you even bother linting these components or no?
I hear your question. It's a challenge because, yeah, the linting will, yeah, your linters are good.
Yeah, I can ignore this if I wanted to. I just didn't. But yeah, I would ignore these parentheses. But let me just go over to Eric's. I know someone's probably going to call me out on the internet or something. This is a service. So this lifecycle really only makes sense for a component, right? So I kind of made the mistake of just adding those life cycles in there. But anyways, I just want to do the disclaimer stuff. So haters online, my bad.
Yeah, so if you linted this file, it would throw an error. It absolutely would.
Yeah, you would just have to like make some rules.
At least I think in ours, files is specifically excluded from linting because it's never going to pass. Right?
So you don't have custom linting workflow for these type of files?
There might be some that exist.
The app you do, right? Like the output of this will be linted when it becomes the app.
But, I mean,
but in this sense, in this specific location, no, we are not actively linting this file.
Yeah.
I don't even know if you could because what is it? It's half EJS and half TypeScript and
maybe there is one. I'm not aware of it and never really thought about it either. I was kind of just like, it's whatever. But yeah.
Well, we see what's generated, and if that throws a linting error, we know we need to go back and fix it.
I mean, I thought that's where you were going. Like, how do you keep this up to date? And that's definitely a challenge. Like, hey, I made a change to like our app that really should be part of the base app. Go open a GitHub issue, open a Jira ticket.
Like if you were to automate application creation at some point down the line, right? You need to lint this stuff first before you.
So you're talking about just more of just like validating it works, like unit testing it?
Just validating the templates themselves.
Yeah, I mean you could do that, but you can also write unit tests and just make sure it works as well. So you can do both. You can lint it as well. I don't know if a linter exists for something like this, but you can just validate it by also just writing unit tests and making sure it's just working correctly, right? That's just one other way to go about that. So if the linter does exist for this, leave a comment. On YouTube. Yeah. All right. I don't know. I'm just rambling on. Yeah.
All right, I'll ask you.
No, keep going. It's fine.
Why Jest instead of Karma? Is that a secret?
Speed, in my opinion. It runs a million times faster.
In Angular, even Karma, when you run Karma, it fires up Chrome to run your tests.
Yeah.
And so with Jest, it just goes. They run, your files run in parallel.
And
I made the decision, so I'll own it. It was the new hotness, and I wanted to play with it and learn it, and I liked it.
Yeah. I mean, honestly, like the syntax, when you like convert your project from Jest, from Karma, Jest is still built on Jasmine, so you can still use the exact same APIs. There'll just be some, other than this boilerplate, which you could use a schematic for, there would be very small changes, syntax changes you have to make. It'll be very familiar if you're familiar with writing stuff in Jasmine already.
Are you sharing any of this inversion to Jest schematics?
So there's actually a bunch that already exist online. So this one's internal to our company, but maybe one day I'll write one. But if you just like Google schematics Jest, some other guy wrote one already too. So, yep. Any other questions? Cool.
Okay.
All right. Awesome.
Thank you. Great job.
Yep. Thank you.
Are you able to stick around for another 10 seconds?
Yeah.